was on measures of central tendency. What is central tendency? Measure of central tendency is basically how do we find the center of our data. A measure of dispersion. Dispersion is how spread out our data is. So for instance, like just a very informal idea, maybe you graph two things and one of them looks like this and one of them looks like this. Which one has more dispersion? The second one. Why? It's more spread out. So dispersion is telling us how spread out. Are all the values really, really close together, or are they really far apart? And just like with central tendency, we had a few different ways of measuring that. We talked about the mean, median, and mode. The main two were the mean and median. Mode doesn't really tell us a whole lot, but mean and median we talked about. When is it best to use the mean to find your middle? With symmetric or bell-shaped. When is it best to use the median? If it's skewed, one way or the other. So we're going to look at a couple different ways to measure dispersion and talk about when we should use each option. So the first thing I have on here is just an example. So if I want to order food at McDonald's, you have to choose from multiple lines. But at Wendy's, you enter a single line. So this data gives me the wait time in minutes in line for a simple random of 30 customers at each restaurant during the lunch hour. For each sample, I want to find the mean. So here's my Wendy's, here's my McDonald's. How do we find the mean? Add them all up and divide by the total. Would these be X bars or mu? X bar, it's a sample. It even tells us up here a random sample. It would be easiest to do this on the calculator. So we talked about finding this stuff on the calculator. When we did it yesterday, we only had one set of data. So we could do these two separately. We could put in one of them, get the value, clear that out, and then put in the other. To speed things up, we can actually enter both of them at the same time. So when you go into your lists, you have L1 and L2. Let's enter Wendy's in L1 and McDonald's in L2. But you can enter more than one thing at once. So if we go back into stat and calculate. Yesterday we did one variable statistics because we only had one set of data. So we have two sets of data now. So we're going to do two variable statistics. All right, we have to make sure these things are correct. So the X list should be L1, the Y list should be L2, so that we have both of those lists in there. Frequency list, don't put anything there. And then if we calculate, I'm wanting to compare the mean for each. So L1 was my X, so it tells me X bar is 1.39. So the sample mean for Wendy's.
Last call for anyone who wants to enroll in dual credit classes with NACC. You need to report to the counseling office at this time. Last call for any student wanting to enroll in dual credit classes.
The second one, it calls it Y bar. It's still a sample mean. They just use Y to distinguish between the two. So it tells me my Y bar is 1.389. So I have a sample mean for each of these. The benefit of putting both in at once is that I don't have to delete one out to do the next. So if I had to go back and change a point, I can do it really quickly and it's all recalculated for me. If you didn't get those exactly, that just means you mistyped a value. It's not a big deal right now. You don't have to go back and find it. I just want you to know how to get it on your calculator. So looking at those, is there a big difference? No. At Wendy's, you're going to wait 1.39 minutes. At McDonald's, you're going to wait 1.389 minutes. So it looks like it's pretty much the same. When you looked at these points, did they all look the same? Did you notice anything? Okay, McDonald's, it has a lot of really fast times. It has zeros, but then it also had some high ones, didn't it? This person had to wait 4.5 minutes. But when I look at Wendy's, what do you notice about those times? They're pretty consistent. Looks like the highest one here was, what, 2.94? So they were more consistent. So we had about the same mean, but I want to know, does that mean it's the same at both restaurants? So we could look at histograms. When I look at this one, so here's Wendy's, here's McDonald's. What do you think? Wendy's, almost everybody is right here. McDonald's, if you don't get served immediately, you might end up waiting for a while, right? So which one has more dispersion there? McDonald's, it looks like it's more spread out. So when I look at these histograms, it seems like McDonald's is less consistent. Okay, so if I only looked at the mean, I would assume it's the same at both restaurants. But if I look at these graphs, I can see, well, Wendy's, I can pretty well plan to wait between 30 seconds and 2 minutes. But McDonald's, I might be waiting up to 5 minutes before I get my food, or before I get to order. So what we need to do is be able to quantify how spread out are these. Can we give it a number? Can we give it a name? So the first thing that we can look at is the range. Range is something you've done before. It's just the difference between your largest value and the smallest value. If you look on your formula sheet that I gave you, go ahead and keep a copy for myself. So on here, yesterday we talked about population mean and sample mean. So the third bullet says range, largest data value minus smallest data value. So we just subtract those. That's the first way we can find out the spread of our data. So for example, going back to that travel times we had yesterday for those 7 employees. If I wanted the range, what's my highest here? 43 minus my lowest is 5, so we get a range of 38 minutes. The second way of calculating the spread of the data gives us more information, but it's much more complicated. This is standard deviation. So it is a big, nasty formula. If you look on your formula sheet, it's the next bubble on there, I think the next bullet, population standard deviation. It has the whole thing. So it tells you, when I'm talking about population standard deviation, this is a Greek letter, it's called sigma. So it is found by this formula. Okay, x sub I, or x sub 1, x sub 2, those represent our original values. What is mu? The population mean. So what it's saying is you have to take your value minus the mean, square it. We add all of those together, divide by the number of points, and do a square root. Okay, this is kind of complicated. So we're going to walk through how to do these by hand. Most of the time we're just going to do it on the calculator. On a test or quiz, I might have you do one by hand just to show that you kind of understand how it's found. It would be a small data set because this is time consuming, so I'm not going to give you 20 points and say find the standard deviation. I'll just give you a few. But most of the time we'll just use our calculator to find it. So let's try this for our travel times. So what I'm going to do is make a table. In the first column, I'm going to put x sub I. That's just our original values. You can put them in any order. You can put them in increasing order, the order they showed up, it doesn't matter. Can I put them in increasing? It just makes more sense. I like it that way. But it totally does not matter what order you write them in. The next thing that we have to do in this formula is the x sub I minus mu. And then we have to square that. Yesterday we found the mean for this. Anybody flip back in their notes yesterday and look what we got for our mean for this? So like 24.9. Okay. I am going to keep a few more decimals. It's actually like 0.857. Here's why. On standard deviation, a little rounding ends up making a big difference on our final answer. So just to try to be a little more consistent, I'm going to keep a few more decimals. You guys all know how you could get your mean. I just got this from yesterday. But otherwise, you add them all up, divide by 7. So here's what we're going to do. So you just go to your calculator. Your first value is 5. Minus the mean. So 24.857. And I get negative 19.857. And then what do we have to do to that value? Square it. So then if I just hit the square, I get 394. Oh. 0.3004. Okay, so next point was 18. So 18 minus the 24.857. Get negative 6.857. Then we square that. You get 47.0184. Does everybody see where I'm getting these numbers? So the calculation itself isn't complicated, it's just time consuming. So 23 minus 24.857. Negative 1.857. Square that. Since I have 23 twice, I'm just going to copy that value down again. And I have 26. Everybody get all this? So now, we have to do the next step in the formula. This symbol means sum. So what we're going to do is add up all of these values in that final column. So add those up. Then the formula says we have to do the square root of that number divided by n, which is the number of points, and we had 7 points. So square root 902.8568 divided by 7. So my standard deviation is 11.3569 minutes. At this point, we don't really have a concept of what's a big standard deviation and what's small. We will learn that anything bigger than 3 is a pretty significant standard deviation. So looking at this, that is pretty high right now. We can really just compare data sets. You know, the bigger the standard deviation, the more spread out your points are. So that's really what we're getting at right now. Are there questions on that? Okay, so that's population standard deviation. Sample standard deviation is similar. So the notation, the variable for that is S, which again, you don't really have to memorize the variable because if you look at your formula sheet, it says sample standard deviation, S equals. So you know S is the sample standard deviation. It's the same idea. It's your value minus the mean. Here we have X bar, the mean of the sample. The main difference is you divide by n minus 1. So that n minus 1 is what's called degrees of freedom. We'll touch more on that later, but it has to do with if you were to add up all of these values minus the mean, they should add up to 0 because it's the distance from the mean. So you should have, if you have the true center, the same amount above and below the mean. And so it's called degrees of freedom because if you knew all the first however many, you could figure out what the last one had to be because it has to add up to 0. I'm not going to test you on that right now, just kind of a side note, but that's why it is what it is, but right now you just really need to be able to use the formula. And it's given to you on your formula sheet, you don't have to memorize it. So, I want to do sample standard deviation here, but I just gave you 3. Okay, so this is not everyone because our company has 7 employees, I only gave you 3 of them. So we need X bar. We need the sample standard deviation, or the sample mean first. So how would I get that? Add them all up and divide by 3. I will caution you, like on standard deviations, how many decimals you round to makes a big difference, so just make sure you're showing me all your work and I know where you got your answer. So then we're going to set up the same way. We'll take each value, the value minus the mean, and then we'll square it. But we only have to do 3 of them this time. Remember, we're using the mean for my sample, not the entire population. So I have to do 5 minus the 22.333. And then square that value. Once you get that, what do you do? if you look at your formula, this symbol means sum, so you add those up, this last column. So then to get my sample standard deviation, we take that number. Here's the one piece that's different. What do we divide by this time?
N minus 1.
N minus 1. So what my N here is 3. We had 3 points. So 3 minus 1 is 2. So we get a sample standard deviation of 15.82 minutes. So which is more spread out? The whole population or my sample? The sample is more spread out because it has a higher standard deviation. I know it's time consuming. Do you guys all understand how to find it? So again, my rule will be like on a quiz, if we need it more than once, I might have you do it by hand one time, and then after that we're going to use our calculator. So everybody still has this data entered into our calculator, right? For the McDonald's and Wendy's, hopefully, if you had it the first time, still there. If you didn't, then share with a partner if you want, or just watch me. So I want to compare the standard deviations for each of those. So when you go to your calculate, we did 2 variable statistics. X was L1, Y was L2. And it gives us a ton of stuff. All we looked at before was the mean. But you notice right here, it gives you S sub X and sigma sub X. That stands for the sample standard deviation and the population standard deviation. So you have to pick, was this a sample or a population? Sample. So we would want the S. So the standard deviation for this one, that was my L1, is 0.7384. So for Wendy's, we just have to go down our list until we get the S sub Y, so that means standard deviation for Y, and that's 1.2649. So didn't we already say, oh, I flipped them this time, didn't I? Sorry. Do you guys see I flipped my tables for some reason? That's not confusing at all, is it? I don't know why I did that. Was it 2649? Okay. So didn't we say when we looked at the graph that McDonald's was more spread out and less consistent? Look at the standard deviations. McDonald's has a higher standard deviation, which tells us exactly that it's more spread out. It's less consistent than Wendy's. So which one would you pick? Knowing that they have the same average wait time, if I look at the standard deviations, which one would you go with?
I'm still going McDonald's.
You like McDonald's better? I don't know. Wendy's has good frosting. But Wendy's is going to be more consistent. So you're going to wait about the same amount each time instead of sometimes getting in really fast and sometimes taking longer. All right. Is that okay? So the next piece, variance, is just the standard deviation squared. So when you look, you know, we have this whole thing, standard deviation, then it has population variance, sample variance, it's just sigma squared or S squared. So it's very easy to find once you have standard deviation, you just square that number. It again is just another measure of how spread out things are. We're not going to use variance very often. We'll usually just stick with standard deviation, but I could ask you to find it. And it's just a very simple calculation there. So if I ask for the sample variance for this one, we did the standard deviation, right, on example, which example was that? 3? Is that right? So when we look back, when we did all 7 employees, we got a standard deviation of 11.569. So the population variance is sigma squared, so I'm pulling that, what did I just say?
569. Oh, what did she say?
3569, is that what we said? Or what? Sorry, I don't remember. Okay, and then we square that. Okay. In example 4, we found the sample standard deviation. So for the sample variance, we just square that. So we had 15.82. Squared. And again, right now, all we're really looking at, the bigger the number, the more variability there is, the more dispersion, the more spread out. We can tell from the standard deviation that the sample was more spread out. We see the same thing with the variance. It has a higher number, so it's more spread out. I think I'm going to stop here. So we're not done. Tomorrow I am going to finish this. We'll talk about a couple of rules and a weighted mean. So this homework, let me double check that this is what is this what I have printed on yours? I think I changed it. I think I maybe took off, did I have like 12 through 18 even on yours? Okay, so just change your assignment real quick. I took off problem 16. So this is your homework. We don't know how to do all of this yet, but a lot of it you do. So this will all be due, let's see, today Tuesday, so we'll finish this tomorrow. You will have some time to work in class tomorrow as well. It won't take me the whole class period to finish up the notes, so you will have some class time. And you have some time to get started right now. I really would like for you to do one standard deviation by hand, but not necessarily all of them. So how about 14 would be a nice one. How about on 14 you do by hand for the standard deviation? The rest of them you can use your calculator. So I just want you to try at least one. You can do more than one by hand if you